You drive? Okay. Make sure you drive safely. Wear your seatbelt.
Thank you.
No texting while driving.
Today is, what's today?
Today's the 2nd.
Second, all right. It is it is 4:15. I cannot read today. Thank you. Thank you.
You're welcome. You're in a rush today?
Yeah, I got to Church Street. It's going to take me 2.5 hours to get home, and the thing starts in 2 hours, so I got to go.
We'll drive safe, no texting while driving.
Will do. Thank you.
Wear your seatbelt.
So I really need to do my Cal videos, but I don't really know what to do it on. Hey, look, there's a truck coming in. It's coming really fast. Maybe I can use that. Yeah.
All right, so in this problem, we have a person who's viewing a truck. The truck is coming toward them at about 25 miles per hour at about halfway, so at 175 feet, because 350 divided by 2 is 175. So the truck is coming at them at about 25 miles an hour, or in feet per second, that is about 29.3 feet per second. And they're standing about 15 feet away from the road where the truck will be coming by. So we have a dy value, which is the rate in which the truck is going on the y-axis. And we're also going to need to find a theta value. So what we'll have to do is we'll have to take inverse tangent of 175 feet over 15 feet, which is y over x. That gives us a theta of 1.485 radians. So keep that in mind, we'll need that for later. So we'll move to the actual problem. So what we're going to need to take the derivative of is tangent theta equals y over 15. When taking the derivative, you get secant squared theta, derivative of theta equals 1 over 15 times dy over dt. When you rewrite it, that is derivative of theta equals dy over dt all over 15 secant squared theta. So, moving it down, derivative of theta, when you start plugging in numbers, is negative 29.3, which is the feet per second. 15 times 1 over cosine squared, and then the radian from earlier. 1 over cosine is the equivalent of secant, so that's where that comes into play. So derivative of theta the derivative of theta equals 0.0143 radians per second. Now for this equation, we see it being more useful to have degrees per second. So to convert radians to degrees, you multiply by 180 and divide by pi. So you have 0.0143 radians times 180 divided by pi equals 0.823 degrees per second. And you need to take the absolute value because that's the rate of change. So when y equals 175 feet, derivative of theta equals 0.822 degrees per second.